Hello, everyone. Let's start. Okay, I'm going to go over what we did last time. So let's see. See. So this is from last time. Just go over that. All right. So this is the ellipse, and for this ellipse here, the major axis is on the vertical axis, right? So in this case, the A should be from the y-axis here, right? We usually assume that A is bigger than B is bigger than zero. So we always have that one here, right? And this is the same thing, right? Okay. And let's see, find the standard equation of ellipse with the center at the 0, 0 and passes through two given points. Where if the center is at the 0, 0, so we can have this equation here, right? But be very careful. The notation is a little bit confusing because if you don't want to use the A and B, because usually we want the A to be bigger than B, but if you make this assumption here, maybe you shouldn't use the A and B. You can use the C and D so that you don't be confused, right? Because when we say A and B, A and B are just some numbers. So it doesn't mean one number is bigger than the other one, right? We just solve the equation and and then let the equation to decide what's the value for A and what's the value for B. So when we do this kind of question, it doesn't mean A is bigger than B. All right, just let you know. So set up the equation, right? You have the 2 points. Each point give you one equation. 2 points, you get two equations, two variables. You can do that. And now the next question is that where what happens if the center of the ellipse is not at the origin, where this is similar to the circle here, right? If I have a circle at the origin, I get x squared plus y squared equals r squared. But if I move the circle center to the hk, then for the x value, I have to have x minus k. For the y value, I have to use the y minus k. Now, it's the same thing for the ellipse, right? That's the original equation. That's a new equation, right? So it's just an x minus something, right? Okay. All right, so you got that. And this is just an example. So and it says, suppose I give you this picture. How do you figure out the standard equation of this ellipse? Where so first of all, you need to take the center. So where's the center? Where the center is here. The center is 3, -2. So that means for the x value, we should have x minus 3. For the y value, we should have y plus 2, right? It's a x minus the x value of the center and y minus the y value of the center, right? So that's why you get that. Okay, well, how do you get that 2? The 2 basically is the distance from here to here, right? That's the minor axis. And where you get that 3? 3 basically is the difference between that one and that one here. Oh no, the other one should be go over that, right? Go over that. So that's why it's equal to 3. Does it make sense? Right, so you get this. Okay, okay. And I think anything else? And okay, yeah, just similar example. So finally, this one, find the equation of the ellipse with the center, right? If you know the center is -3, 2, and now you get that. So the x value, for the x, I should have the x plus 3, right? For the y, I should have y minus 2, right? And then divide by the a's and b's, right? And then we can use the two more vertices, right? So here's a 1 point, another 2 point. We set up the two equations, right? So these are the two equations and solve the equation. Usually that should be okay. All right, so that's what we did last time. Okay, and last time we actually give the definition for a parabola. Okay, that's a new definition. So we know the parabola from the y equals ax squared plus bx plus c, right? That's another definition. That's from the functional point of view. But now we're going to from the geometrical point of view. So how do you define that at that point where the parabola is defined to be O of the point P such that you have the, you first of all have one point called the focus. I'm going to call that focus here, right? And then another straight line called that the directrix. So this is called the directrix, okay? One straight line and one focus. And now how do you define the parabola? The parabola will be all of the points, okay? Will be all of the point P such that the P satisfy this condition. So what's the condition here? It's the distance between the P and the focus. Okay, that distance is the same as the distance from P to the directrix. So that means I want this distance to be the same as that distance, right? You get a fixed point, right? You get a fixed line, and then I want to get all of the point P such that P has the same distance to the focus and to the directrix. So what are the P? Right? I got the knots of P's, all of the P's together can form a curve, and that curve is called a parabola. So how do you do that? Where the first one, you have a distance formula here, right? So this is the distance formula, and the other one is just the absolute value of the difference of the y. Solve this equation magically, we get the equation of x squared equals 4ay, and that is just a parabola, right? That is just a function of the degree x2, right? Degree 2, right? So you can rewrite that y is equal to some number then times the x squared, right? A number times x squared. Well, this is just a usual parabola. Does it make sense? So the two definitions, they're actually the same, right? They're actually the same. But the second definition is from a geometrical point of view, and you got the focus, and I'm going to show you, what's the important part for the focus, okay? And then we have some application for today. Are there any questions before we move on? Okay, so let's see. Today, okay, let's see. We're going to do the. All right, so today I'm going to start with the where what happens if the vertex is moved to a general point. Okay, so let's see. So I think last time we get. And let me draw the picture here. So I'm going to get the. All right, so let's say we go from here. All right, we get that. And then last time we have the parabola. So let's say the parabola may be something like that, right? Like this. And this is the focus, right? And this may be the directrix. The directrix is here. So the focus is here, and that's for the A. And this is for the negative A here. And this is the vertex. This is the vertex, right? And the equation is the x squared equals 4ay, right? That's what we did last time, okay? But now today, let's say, suppose I want to shift the vertex. I want to make a translation, right? Translation means that you can move the picture horizontally or vertically, right? You can do that. Okay, so let's say, suppose I move this to a point here, and this is the vertex with the horizontal, with the x value of h and the y value is the k here. And then I can draw the picture like something like that, right? So this is my picture, right? So how do you write down the new equation of this parabola? Okay, so I get a new parabola here. The vertex is, so this is a new vertex. It's a vertex, right? Becomes h and k. So how do I get that? Okay, so first of all, I'm going to write down the following important data. The vertex now is hk, and now where's the focus? Where's the focus? Originally, it was here, right? Originally, that was 0A, but now when I move to the new spot for the focus, right? The focus is here. So basically, for the x value, I'm going to add the h, The x value is added by h. The y value, I'm going to add a. So the focus will be this, right? It's just the a units above the vertex. Now, where is the directrix? Where the directrix is here. So this will be the y is equal to k minus a, right? So the directrix is y equals k minus a. Okay, and now I need the equation. So the equation I need will be, well, it's the same as before. If you just remember what we did last time when we talked about the ellipse, right? If you look at that's a basic idea, right? That's a basic idea. If you move the center from 0, 0 to hk, the x value will be subtracted by h. The y value will be subtracted by k. So that's the main idea. Okay, I'm going to just show you here. The main part is just his. All right, so x is replaced by x minus h, y is replaced by y minus k. Okay, so let's do, what do I do today? Well, this is my original equation. Okay, if the vertex is at the origin, right, 0, 0. But now the vertex is moved to hk, now you do the same thing. So the new equation will be, I'm going to have the, so let me write down here. Uh, Basically, it's a following. The original equation is x squared minus 4ay. The new equation will become, I'm going to have x becomes the x minus h, and the y becomes y minus k. It's exactly the same thing. Okay, your x value is replaced by x minus h. Your y value is replaced by y minus k. So that is your new equation. Or I can rewrite that. So if you want to write in terms of the y equals something, so you can write this to be the following. You can write the 1 over, let's see, it's a 1 over 4a times x minus h squared equals y minus k, right? So you divide both sides by 4h, and then you can write the y is, let me switch the side, because usually people want to write the right y from the left-hand side. So it's a 1 over 4a x minus h squared m plus a k. So you got the, you can use either one of that. So you can have the, you can have, let's see, all right, so you can have either this or you can have the other one. They are both acceptable. All right, they're both okay. So here, let me just give everyone a few seconds. So this is a equation for writing a parabola if the vertex is not at the origin. Okay, if the vertex is not at the origin. All right, so that is here. And just add some comment is that where if you look at that where some of the parabola opens upward, some of the parabola opens downward, right? And then we know that it's decided by the a. So it is decided by the a here. So if a is bigger than 0, the parabola opens upward. Okay, the parabola opens upward. So that opens upward. Okay, opens upward. And if a is smaller than 0, then you have the parabola opens downward. Okay, and how do you get the a here? How do you get the a here? Let's take a look. How do you get a? A basically is a difference between the y value of the focus and the vertex. So I can use the focus, the y value of the focus minus the y value of the vertex, not the other way, right? Because the plus or minus sign does matter in this case. So how do I get the a here? So a is actually the y value of the focus. Okay, y value of the focus minus the y value of the vertex. Okay, so that's how you compute a here. All right, is that okay? Now I'm going to give you some examples. So let's try some example. Let's try some examples. So find the equation. Find the equation of each parabola. Equation of each parabola. So the first one is that well, suppose the center is at the 0, 0, and the directrix is y equals 5. Okay, y equals 5. The center is at the origin. So where is it? How do you draw the picture? Okay. Where the center is at the origin. So let's say this is center, right? So this is the center. And then y equals 5. That's the, so y equals 5. So let's assume that you get let's see. Suppose this is y equals 5. No, I don't use the arrow, just use the straight line here. So suppose this is y equals 5, all right? Y equals 5. And this is the center. This is the center is 0, 0. So how do you define, how do you draw the picture? Where if you look at the picture here, if you look at the picture here, the distance between this part, right, this part is the same as the distance of the other part. You can see that the both have the distance of A. So that's how you identify the vertex, the center, the vertex, the focus, and the directrix. That's their relation, okay, among them. So let's go back to here. What can you say? So where is you know the center here, and where's the focus? Where the center should be in the center. The vertex. I mean there should be the vertex, not the center, right? Because when we talk about the center, we're talking about the ellipse. So I'm gonna redraw it. It's not the center. It just means the vertex, right? So it's a vertex, right? This is a vertex. The vertex is just between the focus and the directrix. So if the vertex is here, then this is just a focus, right? And then your picture will be something like that, right? This will be your parabola. So let's see, how could I get that? Well, this equation, basically the equation will be that x squared equals 4ay. Why? Because the vertex. If the vertex is 0, 0, then we go to the original equation. It's x squared equals 4ay. But what is the A? A is the difference, right? A is the difference between the focus and the vertex, or the vertex and the directrix. So how do I get A here? A is just that 0, right? That number 0 and minus the 5. So 0 minus 5, that's equal to 5. And it's negative. Negative just means that it opens downward. Okay, so that's equal to 4 times 5 is 20. So it's negative 20. Y, there's no square here, right? So this is my equation. Okay, everything's good? Right. Everything's good, right? So this is the first one here. That's so far so good. That's a warming up. Okay, next one. Let's say now the vertex is not in the center anymore. All right, so vertex, second part here. Let's say the vertex is at 4 and 3, and the focus is at the 4, -1. Okay, let's try that. I give everyone 30 seconds. All right, so you need to figure out the first of all, draw the picture. Where is the focus? Where is the vertex? And where is the directrix? And the most important thing is that how do you find the A, the value of A? The value of the A is always the focus minus the vertex. Okay, so let's see. The vertex, the focus. So let's see, the vertex is a 4, 3. So let's assume that the vertex here, V, let me use V. The vertex is a 4, -3. The focus is a 4, -1. So it's above that. The 4, that's a focus, right? It's a 4, -1. All right. And now this is actually the symmetry, right? The line of symmetry here. And so where is the where is the parameter? Where is the parameter? The parameter should be in this way, right? The parameter should be in this way. Okay, so I got that parameter. So the parameter is in this way, but now the vertex is 4, 3. So from here, I can tell it's x minus 4, take a square, right, equals 4a times y minus 3. Can you see that? So 4 goes here, and -3 goes there, right? That's the way to draw a parameter, right? To write the equation of the parameter if the vertex is not at the origin, right? The x value goes to the x minus something, right? The y value of the vertex goes to the y minus that number. Okay, but now where can you get the a here? A is just the focus, right? The -1 minus the vertex. So it's a focus is here, minus the vertex is here. So it's a -1 minus 3, and that's equal to -1 plus 3, that's equal to 2. So what's the answer here? The answer is the x minus 4 take a square is equal to 4a. A is equal to 2, so 4 times 2, that's equal to 8. And then y minus 3, that's equal to plus 3. Okay, so that's my answer. Okay. All right, give everyone some time. Okay, next question. Let's try this one here. Suppose the focus is -1, -5, and the directrix is y equals 2. Okay, give everyone some time. So let's think of that. Right, the focus. So first, I'm going to draw the directrix. So the directrix is, let's say, y equals 2. Okay, the focus is -1, 5. Is that above the 9, or is that below the 9? Where -5 is smaller than 2, so it should be below the 9. Okay, so let's say, suppose I get, I guess, a stuff here. So this is the focus. Use f, -1, -5. All right, you get the focus and you get the directrix, but where is the vertex? Where is the vertex? The vertex should be somewhere in the middle, right? Because the distance between the focus should be in the middle, right? So this is a vertex here, right? Vertex is just right in the middle. It's just right in the middle. So this is the vertex here. And now can you tell me what are the coordinates of the vertex? Okay, what are the coordinates of the vertex? So let me use V for the vertex. Okay, vertex, the x value will be the same because it's on the vertical line, right? The axis of symmetry should be on the vertical line, so it's the same x value. How about the y value? That's tricky. Well, it's just right in the middle, so it will be the average number of 2 and -5. So I will get the -5 plus 2 and take the average, right? You get 2 here, you get -5 here, the average of them, and that's a position for the vertex. Okay, so simplify that, I can get the -1 here. And then -5 plus 2 is -3. -3 divided by 2 is a -1.5. So this is a vertex. And then the picture will be maybe just something like that, right? So that would be the, my picture was not very good. All right, so let's see. Maybe let me draw again, somewhere like this, right, somewhere like that. All right, so these are parameter here. And now the question here is, how do you get the equation? How do you get the equation? Okay, go from the vertex. Right. So if you go from the vertex, you can write down the equation, right? The equation basically is x squared equals 4ay. Okay, x squared, but then x is should be minus 1, right? X squared equals 4ay, but y should be y minus the y value of the vertex. Does it make sense? Right, so this is -1 goes here, this -1.5 goes here, okay? And now I just need to figure out what is the value of a. What's the a here? A is the difference between the focus and the vertex. The focus is -5, and the minus the vertex. The vertex here, the y value of the vertex is -1.5. So it's -5 minus 1.5, and that is -5 plus 1.5, right? And so that just becomes the -3.5. Okay, that becomes -3.5. Everything's good? And so I can write down my final answer for this. My final answer should be the following. So I'm gonna get from here, it's x minus 1, so it's x plus 1 equals negative 3.5 times 4. 3.5 times 4 is equal to 14 times y minus 1.5 is plus 1.5. So that is our answer. Okay, that's our answer. Okay. All right, give everyone some time. And certainly, if you wish, you can. Some people are not don't like that kind of form. If you go from a geometrical point of view, this is a standard form. But some people like to use the other way. So if you want, you can. So equivalently, you can write your y equals. You have the 1 over -14, right? So it's a -1 over 14 x plus 1 square, and then you minus 1.5. That's also fine. So it's up to you. Okay, it's up to you. So this is also a good answer. So either way, some people prefer one way, some people prefer the other way. All right, everyone's good? Excellent. Now, I'm going to give you another form for the parabola. So far so good. The parabola is opening up, or the parabola is opening downwards. But what happened if the parabola could open to the left or could open to the right? Okay, right? So in this case, let me just write down the equation here. So let's say, so assume that you have the following. So let's say, again, let me just use the, all right, so we can get that one and assume that we have the parameter goes this way. All right, in this case, this is our focus is here, and then the directrix is here. So this is directrix, right? This is A here, and this is x equals -a. And we can do the same thing, right? There's no much difference. The only difference is you make a rotation, right? Rotation by 90 degrees. The previous one opens up or opens down, and this one it opens to the right or opens to the left. Does it make sense? So how do I write this equation? Well, I give everyone 10 seconds. Is there any faster way to write down this equation? Okay, if you're confused, let's just go back to the first picture here. If I have the parabola opens upward, right? The equation is that x squared equals 4ay. So what do I do if I have a parabola opening to the right? Like that. Where you can say there's no much difference. The only difference is just a switch of the variable, right? So if you just say, well, if you just say this is my y value and this is my x value, I just switch x and y, and then it just becomes the other one here. So basically, you just need to switch x and y. Okay, so that one is a y squared equals a 4ax. Just switch x and y from the previous picture, because in the previous picture, right, the parabola opens to the y-axis, and here the parabola opens to the x-axis. So x and y just switched, and so you can get the y squared equals a 4ax. Okay, and similarly, suppose I have h and a k, right? So this is h and this is a k, right? H and a k, and then you have the parabola opening horizontally, right? Either to the left or to the right. Now, how can you write down the equation? Okay, give everyone 10 seconds. How do you write down the equation? You just change your x value to x minus the x value of the vertex, right? So you just switch your x, right? X is replaced by x minus h, and y is replaced by y minus k, right? You switch your x into x minus h, you switch your y into y minus k. So the equation becomes the following. The equation becomes y minus k, right? Originally, that's a y squared. Y squared becomes y minus k, take a square. Right-hand side for a x, the x becomes x minus k. So this is our equation. All right, give everyone some time. So that just makes sense, right? Just switch x and y. That's always the same. Okay, any question? Give everyone some time. Everyone's good? Very good. So now I'm going to give you some example. So let's try the following example. Find the equation of a parabola with a focus at -5, -2, and directrix of x equals -1. Okay, so let's think of that. You got the equation of the parabola, okay, the vertex and the directrix. The directrix is a vertical directrix, so that means the parabola opens horizontally. Okay, so let's see. Let me just get the we get that. Okay. So that's a directrix, x equals -1. X equals -1. The x value is -1. Now, where's that focus? The focus, the x value is -5. So that means way to the left. Okay, so I'm gonna get that. So let's assume that this is the vertex. This is the focus. Okay, the focus is here. The focus is -5 and -2. Okay. So how do you write down the equation? Again, I need to identify the vertex. The vertex is just right between them, right in the middle. So where is the vertex here? The vertex should be somewhere here, right? This is the vertex, and then I can get my parabola. Okay, so how do we get the vertex here? The vertex. Uh, think of that for a couple of seconds. The vertex is just in the middle, right, between the focus and the directrix, right? Okay, so I know that the x value will be the -5 and then plus the -1 divided by 2. So it's the average of the two numbers, and the y value will be the same of as -2, right? Y value should be the same as the focus, the y value of the focus. So we have -5, -1, that's -6 divided by 2, that's -3. So that's a -3, -2. All right, we get that. And now let's try to write down the equation. Okay, I give everyone 10 seconds. Let's write down the equation. The original form of the equation should be y squared equals 4ax, right? Original. So y squared equals 4ax, and that becomes what? Because the vertex is switched, right? If the vertex is there at the 0, 0, then you can say it's a y squared equals 4ax. But now the vertex is here. So this is the vertex. If the vertex is here, then I get y minus 2, right? Take a square, equals the 4a, and x minus the x value of the focus, right? Okay, almost done. But now where's the a here? How do you get the a? How do you get the a? Oh, by the way, we have the a. If a is positive, if a is positive, if a is bigger than 0, the parabola opens to the right. And if a is smaller than 0, the parabola opens to the left. Okay, the same thing, just switch the x and y, right? Same as before, right? The previous one was that if the, I think it's here somewhere. Right, so if a is bigger than 0, it's open upward, right? But, and then you can see that. So if a is bigger than 0, it just open to the right, right? And otherwise it opens to the left. So if a okay, I open to the right. If a is smaller than 0, I open to the left. Okay. Everyone's good? All right, so but I still need to figure out the a here. How do you get the a? A is the difference the between the focus and the vertex. Okay, where's the vertex? The vertex here is the v is -3, -2. So that will be between the difference between the two x values, right? Okay, so it's a focus, it's a -5, and minus the vertex, -3. So I can get the -2 here. All right, does it make sense? And so the answer is the following. You get y plus 2, because it's a -2, right? Take a square, equals 4 times a, but a is equal to -2. So it's a -8. And x minus 3 is x plus 3. Okay, so that's our answer. Right, so that's our answer here. Are there any questions? Okay, or if you want, you can just rewrite that, or you can do the x squared is equal to, divide both sides by 8, so it's a -1/8, right? X, y plus 2, and then move the 3 to the other side, so it's a -3. Okay, does it make sense? Just give everyone some time. Okay, next one we're going to do is that, let me give you one example. So suppose we give you an equation like the general equation. All right, so let's say I want to give the general form of the equation. So given a parabola, which is 12x equals y squared minus 4y plus 52. Okay, I want to find the following. The vertex of the parabola. Okay, the focus of the parabola. The directrix, and then the axis of symmetry. Okay, so let's take a look. Give everyone some time. Uh, the formula, the function was given in not in the standard form, it's in the general form. So can you change this to the standard form? What do you mean by the standard form? Standard form means this, right? It just means here, right? Here is the standard form, right? What I want is that I want to change this to that one. So if you can change me to that standard form, then I know where is the vertex, where is the focus, right? And where is the directrix, and the shape of the parabola. Okay, so that's my suggestion. I'll give everyone, let's say 30 seconds. Let's try that. Okay, so the key idea is completing the square, right? Because you need to have a square of one variable equals something times the other variable. So if you have the y squared minus 4y, I don't need that 4y. So that means I need to put the right-hand side as a square in terms of y. Okay, right, can you do that? So let's see, how can you do this? So you can have, let's see, 12x equals, I get y squared minus 4y. In order to complete the square, I need to add the 5. And then if I add 4, I mean, if I add 5 from the first group, I should subtract 5 from the other group. So that 4 and 4 can be canceled out, right? I subtract 4 because I can get a perfect square. So the right-hand side is my y minus 2, take a square, and plus 48. Okay, and that's not my standard form yet. My standard form will be the following. I'm going to rewrite that y minus 2 squared equals 12x minus 48. You see that? I subtract 48 because one side has to be just a complete square and nothing else. So if I get an extra number 48, I should move to the other side. Okay, and the other side should be some number times x minus 4 here. So this is my equation. Okay, this is my equation. And after I get my equation here, then we are ready to tell you the vertex. So can you tell me where is that vertex? Okay, where is that vertex? The vertex is a 4 and 2. 4 goes here and 2 goes there. That's a vertex, right? And where is a here? Where this is supposed to be 4a and x minus h, right? So a is actually 4a is equal to 12. A is equal to 3. Okay, a is equal to 3. So that tells you where is the focus. Okay, where I can draw the picture first. Let me draw the picture. The vertex is at the 4, 3, 4, 2. 4, 2 is the vertex. The vertex like that, right? And then the A, so this is a 4, 2. Okay. And where's the A? A is just the where you have to figure out the A. A is equal to 3. So that means if you move from here to here, so this is the vertex and this is the focus. And 3, just because A is equal to 3. So the X value of the focus will be 4 minus 3, right? 4 minus 3 is equal to 1, then I can get that. So this is the, uh, well, actually it's a plus, okay? It's a 4 plus 3, right? So the focus will be the 7, 2, right? The focus will be the 7, 2. Oh, by the way, how do I know the parabola open to the right? Just because A is bigger than 0. If A is bigger than 0, so I get the parabola opens to the right, okay? Does it make sense? Right, so you get the focus here, and then where is the directrix? The directrix is just in the opposite side here. So the X is equal to 4 minus 3, and that's equal to 1. Okay, so that's all of the information here. Just give people some time. Everything's good? Okay, let's see. Here's another example. Another example is that, let's see. I want you to find the equation of the parabola with vertex at the negative 5, 4, and it contains a point of negative 7, 0, and it has a horizontal axis of symmetry. Okay. All right, give everyone a minute. Let's see how we can do this. I'm gonna get some water. Give me 1 minute. Okay. All right, I'm back. Just take some water. Let's see how we can do this. Well, so first of all, draw the picture, right? Draw the picture first. Okay, so let's see. Oops. Right, so can we draw the picture first? Vertex is negative 5 and 4. Okay, so let's see. I'm going to have the vertex is here somewhere, right? Negative 5 and 4 here. And the axis symmetry is horizontal. So this is a horizontal axis of symmetry. So that means the parabola should open to the left or to the right. Okay, I don't know, but let's take a look. It has 1 point. Where's that point? The point is -7, 0. Okay, -7, 0. So we'll be somewhere, maybe somewhere here, right? You get a -7, right? X value is smaller, the Y value is smaller, right? So like that. So I noticed that if you have the 1 point here, then the parabola probably should be like that, right? It should be like that. So that is your parabola. Okay, so first you get the parabola should have the following equation. So what is that equation? The equation will be it's a y square, right? Or if the vertex is the origin, so it should be y square equals the 4ax, right? The vertex, if the vertex is at the origin. But now the vertex is at the -5, 4. So I'm going to have 4 goes here, right? The vertex here. And then x should be the x minus 5. So the x goes here. Does it make sense? Right? And then I just need to decide the a here. Okay, I just need to decide the a here. So we get the following equation, and this is my equation here. So I also get a point here. The point is -7, 0. Okay, or if the point is -7, 0, then I can get the following. So that means I'm gonna have, let's see. Okay, so that means I'm gonna substitute the 0 for the y value. 0 minus 4x squared, 0 minus 4 squared, 4a times x plus 5. But x, what's the x here? X is -4. X is -7, right? And plus 5. Okay, and then you can solve for the a here. Okay, but actually I just need the 4a. So the left hand side is 16, right? 4a times -7 times plus 5 is a -2. So I just need a 4a. 4a is a 16 divided by -2, and that's equal to -8. And then we are done. Okay, so the equation here becomes the following. We get y minus 4, take a square, equals 4a. Where's the 4a? 4a is equal to -8, -8, right? So 4a is equal to -8 and x plus 5, and that's my final answer, right? All right, give everyone some time. Just give everyone some time. So next, I'm going to give you a very nice property for parabola. The parabola is very, very, very important uh, in the sense that it has a very nice property. It's called the reflex, the reflection property. Okay, the reflection property. The reflection property. What is this? Okay, let me explain that then. Well, I think many of you have noticed the Saturnite dishes, right? The Saturnite dish, if you just look like the cross section, right? The cross section of the Saturnite dish, it's actually a parabola. Okay, so basically the parabola has the following properties. Suppose I got a parabola like that, right? This is a parabola. And then if I have some, let's say, suppose this is the focus here. This is the focus, all right? And if I have the parallel lines going into the parabola, right? If I have lots of straight lines, right? Uh, Going that way, and then after it hit the parabola, it's reflected, right? And where does it reflect? Magically, they all reflect to the focus. So that's why the point is called the focus. So everything is just go to the focus here. So this line goes to here, focus going straight in that way, and you got this way here, and then you get that one here, and then you get that one here. So that's a very nice property. And this one can be used to build Saturnite dishes, Saturnite dishes, where you can, where you can just connect to something, right, from a Saturnite, right? Or another one is that you can use this to build the head-night reflectors. Okay, head-night reflectors just mean the opposite way, right? So what you do here is this, right? You have the nights here, so that's a night ball, and the ball can go this way here, and the nights can go this way here. But after the reflection, it always goes in a parallel way, and then that can say, that can build some, when you drive a car in the evening, right? And then that's the headlight was building that way. So that's the headlight reflection for your car. So this is for your car, right? Okay. And now, how much time do I have? About 10 minutes. Now I'm going to show you a proof why a parameter always has such a very nice property. Okay, so let me give you a proof here. So basically, first of all, we need to understand the reflection of the night. Okay, so basically, suppose you get a straight. This is like a mirror, right? And then if you have a night going this way, right, and everyone knows that the night will go out in the other way. But in physics, the rule is that this angle should be equal to the other angle, the angle one and angle two. The angle one has to be the same as angle two. This is a kind of a reflection, right? You got the mirror here. I have the night, right? I have the flashing light, and I want the light hit the mirror, make a reflection, and they keep the same angle. Angle one equals angle two, right? Okay, so let me give you the following example. So that's basically the warming up. So let's see. Here's the example. Okay, I'm going to write down y equals the 4x. I'm going to pick a point, which is 4 and 0. Okay, so let's assume, let's try my best. All right, so suppose this is a focus. Wait a second. Let me go back. Suppose the focus is at the 1. All right, so this is the focus, right? Because if you have the y equals actually y squared, right? Y squared is equal to 4x. So going from here, the focus will be 1, 0, right? Because you need to divide the 4 by 4, right? The focus is 1, 0. So this is the focus here, right? And then if you draw I'm gonna get the 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. I know that this is the point from the so for 4. Okay. So this is this is the point P. P is at the 4, 4, right? And if you double check that, if you apply x equals 4, y equals 4, so this is actually on the parameter. All right, so let's say, suppose I got a parameter in this way. I'm not good at the drawing the picture, so the parameter is not easy to draw here. All right, and then if you go from P here, and you get a tangent line. So suppose this is your tangent line. Let me use a different line. Let's try to use a tangent. I need to get a tangent line. All right, somewhere. Hmm. Let's see. So the tangent line is supposed to be like that. That's a tangent line. All right. So we got that. Anyway, so I'm not good at drawing the parabola. So the parabola is like that, and you got a tangent line here. So this is your P here, and this is your Q. All right, and you make a reflection. So basically, suppose you get straight light. Okay, suppose you get a straight light. It goes this way, goes here, and you want to make a reflection, right? You want to make a reflection uh, going from, let's see, going from here to that spot. I want to show that this line, eventually after reflection, the two lines should be parallel, right? Parallel with the horizontal line. So basically, according to what I did earlier, if I make a reflection, this angle should be the same as that angle. This is in physics, right? And what I want to prove that I want to show, so I want to prove that FP is the same as FQ. So you know what I mean here? I want to show this line segment is the same as line segment. If I can prove this, I prove the reflection property. Why? Because if those two are the same, then the triangle here is the isosceles triangle. If this is isosceles triangle, that means this angle is the same as that angle here. Does it make sense? So I'm going to call that the angle 1, angle 2, and angle 3. If this is the case, then I have angle 3 equals angle 1. But on the other hand, angle 1 is also equal to angle 2 because this is the reflection property, right? And so that means angle 2 equals angle 3. But if angle 2 equals angle 3, that means that the two lines are parallel because the two angles are in the corresponding angle, right? Are corresponding angles. So that just basically shows that if I have this one, it shows that PR is parallel with QR. And that just proves the property here. So these are just the parallel lines. If you go from the focus, you send lots of lines out. After reflection, you just go back to the horizontally, right? Just go back horizontally. Okay, so the question here is that, well, why you have this, right? I have to show this. So this is a big question. Does it make sense? Why I have this? Okay, I probably don't have time to do that. Just tell you the idea. Okay, I'm gonna skip the details. The first idea is that where I'm gonna get the tangent line, right? The tangent line here is, so I'm gonna have, it's a Point-Slope formula. So it is y minus y minus 4 equals mx minus 4. Can you see that? Because I have a point here, 4 is a point. So going this way, I can have y equals mx minus 4m minus 4. So that's the equation of the tangent. Okay, but I also have the equation of the parabola. The parabola is the y squared equals the 4x, and I got the y is equal to mx minus the 4m plus 4. So I get the equation here, right? And for this equation has a unique solution because it's a tangent line. So this implies that we have the following. So basically, let me write down. Give me a second. Okay, so I'm going to have the basically you're going to do the so your mx minus the 4m plus the 4, take a x equals the 4x. Can you see that? You do the substitution, substitute one. This guy has a unique solution. Has a unique solution. Okay, if this guy has a unique solution, and if you know the parabola, right? The y equals ax squared plus the 2x plus bx plus c, right? It's a quadratic equation. The quadratic equation has a unique solution, means the delta is equal to 0. And then you get that equation. It's a little bit complicated. After that, you have m equals 1/2. All right. And if you know m is equal to 1/2, then you get the equation here. You get this 9. And if you get this 9, you got that intersection point. Okay, let me try to finish. Anyway, so you got that point here. And this intersection point for Q, according to my computation, this number is actually, where is that? This is actually -4, 0. So in other words, for this equation here, your answer for x is equal to -4 actually, right? Anyway, so I don't want to write here. And then you can get the equation here. So this side is actually, oops, okay. And this side is actually equal to 5 because it's a 1 minus -4. And the other one, the other side is also equal to 5 because it's a 3, 4, 5 right triangle. This is 3 and this is 4. So this is a 3, 4, 5 right triangle. So that just shows that the two sides are the same. Okay. Anyway, I'm going to stop here and just say a few words about the summer and for the next semester. Okay. In the summer one, actually, I have a free course. I think this is actually suitable for you. It's a book reading, and I choose a book by Terry Stoll, and he's a very famous mathematician. And the book actually was written by him when he was 15 years old. So he was very young, and you will see, how he can have that very nice mathematical idea when he was only 15 years old. Okay, so this is highly recommended for you. It's free. You don't have to pay anything. So just ask your parent to register. Summer 2, I'm going to have another course. Okay, so let's see. Give me a second. Let me write down here. Summer 1, right? This is the book. Read the book, right? By Terry Stoll. Okay. Summer 2, I have a course called the graph theory. And I think this is also very, very interesting. Okay, it's taught at the university level, high upper level university undergrad student, and it's basically about it's a very nice it's an application topic. It's what kind of the graph we're talking about, and I cannot explain in details, but again, it's an interesting a book to read, topic to cover. And next one, we're in the fourth semester. In the fourth semester, where we don't have geometry course anymore. You basically have studied all of my geometry classes, and you are doing very good in geometry. But some other courses you may be interested in, like the MC 10, MC 10, 10 MC, or I can have the 08 math counts. So these are the two courses you could take, right? And for algebra course, not quite sure your neighbor. Some of the choice will be 07 or 08 algebra, and these are the good choices for you. All right, so if you have any question, you can email me or you can ask your parent to contact me. Okay, I'm so glad for teaching you this semester, and hope to see you in the summer or next semester. Okay, I don't have time because I have another class right after that. And if I cannot see you in the future, and just say bye-bye, goodbye. I wish you good luck. Okay. All right. So any question? No question. All right. Thank you.